welcome to our continuation of AWS Solution Architect. Today we are going to be looking at one of the most important sections of our cloud studies, which is the database. So many of you have been hearing of database. They've been telling you that the brain of everything is a database, or the heart of everything is a database. If you should secure your database, if your database is stolen, you have lost all your data, all the importance that have been placed behind a database. Today we are taking a gradual concentration on what is a database, but we are going to be looking at a database from the cloud perspective, because here we are doing cloud studies. So we are going to look at the database from our cloud perspective. We are not going to study database as in we are database engineers. No, we are going to study database as a tool for us in the cloud. So in the cloud, how do we use database? That is how we are going to look at it. We are not going to be database engineer or DBAs. No, we are just going to study how we can interact with a database without having any difficulties. Okay, so but before moving into how the cloud handles database, it is important for us to first of all just understand what is a database. Okay, it's important for us just to understand what is a database, and for that our agenda for today will be, or for this video will be, we are going to look at the two types of databases. We have two types of databases that are in the market or that are existing in the industry. We have the relational database, what we call the SQL database, and then we have the non-relational database. This is what we generally call the NoSQL database. Okay, so for the relational database, we have so many of them. There is Oracle, there is MySQL, there are so many of them. So, but for our case study, we are going to study MySQL. Or if you study one of them, the principle holds the same for all the other databases. Okay, if you take one relational database and you study it like MySQL, you can take the same principles and you study Oracle. Okay, and the same thing will move for non-relational databases. We have DynamoDB, we have MongoDB, and the rest. So, but in our case, we are going to look at DynamoDB. Okay, at the level of the cloud, we are going to look at automatic backup with respect to MySQL, multi-availability, and read replica. What are all these things? We're going to explain that. And with respect to non-relational database, we are going to look at what is their partition key, or what we call primary key, and the composite primary key, what we call the sort key. This is our agenda for today. At the end of today, we are going to understand integrally the role databases play, and then immediately after this video, there is going to be a project on a real life application where we are going to host a real application, and in that application we are going to connect the front end of an application to our database and secure the database just like it is done in the industry world. Secure the database in a private subnet where internet access is not there, and we are going to use a bastion server in order to navigate to the database. Okay, we are going to do all this in our project. It is going to be a second video just immediately after this video, so stay right on and we go through. By the way, let us begin by talking about a database. What is a database? When you hear of a database, what do you think of? So many people, when they hear of a database, they think of a container. It is a container, right? So many people, when you hear of a database, you think of a container. A database is a container, which they are not far from the truth. Yes, a database is a container. Putting it in layman's term, a database is a container, right? Yes, that is a database, which means I can now ask a question. The hard drive in your computer, is it a database? The hard drive in your computer, is it some sort of a database? It is a storage device, but it is not a database. So that brings us to another issue. Is there a difference between a storage device and a database? If I have a storage device and I have a database, is there a difference between a storage device and a database? Yes. A storage device, let us use this as a storage device. This is a storage device, and I think device is like this, I don't know, and this is a database. Now the question is there a difference between a storage device and a database? I will tell you that a storage device is not a database, but a database is a storage device. Okay, which means that if you have your computer, the hard drive of your computer is not a database yet, but when you have a database, that database is already a storage device, but it can only store a particular data in a particular format. This storage device can store objects. That's why they call it storage device. Can store objects and all whatnot. It's an object store, just like it stores objects in the form of maybe pictures. It is a file object store. Okay. Then a database, it stores data in another format. We are going to come to that. Okay, so in a layman's term, a storage device is different from a database in that a database is a storage device, but a storage device is not a database. Okay, just get that in your brain, as easy as that. So how do you make a storage device? Since I say a storage device is not a database, how do you make a storage device become a database? Okay, in order to make this storage device becomes a database, what you do is you install a database engine. You install a database engine. When you install a database engine in your storage device, then that storage device now becomes a database, right? When you install a database engine in your storage device, that storage device becomes a database. What are the various database engines that we have? We have MySQL. It is a database engine. That's what we said we are going to study. Okay, we have Oracle. Let's just go there and we see the various engines that we have. Let's go to database. We are first of all still talking about relational database, please. So let's just go to RDS. When you go to AWS, you type RDS, you come to relational databases. Okay, if you come to create database, let's see the various engines that we have. We have Aurora, we have MySQL, Aurora MySQL, we have MySQL single, we have MariaDB, we have Postgres, we have Oracle. These are all database engines. Okay, these are all database engines. The one that you are going to install in a storage device will now transform that storage device into a database. You see, the database is still inside a storage device. That's why I said a database is a storage device, but a storage device is not a database. I hope you understand now. So the combination of a storage device and a database makes this storage device becomes a database. Okay. Second thing, why do we have two types of database? Why do we have two types of database? Because here I have said that we have relational database and non-relational database. Why do we have two types of database? The reason that we have two types of database is that this database like this is just made up of rows, so many rows. When you install, your storage device did not have all these so many rows. Your storage device never had these rows, but a database has so many rows and columns. Okay, a database comes inside now with so many rows and columns, and then there are columns like that, like that. Okay, this is how a database comes. It comes with so many rows and columns. Okay, so how is a database different from an Excel sheet? There is basically no difference of the database from an Excel sheet. It's just that a database has so many rows, more than an Excel sheet, and so many millions of columns, more than an Excel sheet. An Excel sheet has a maximum, a certain number of columns that it cannot go, and a certain number of rows that it cannot go. But a database has more than that of an Excel sheet. Okay, now there are two types of databases. One comes with rows and columns. That means your data is stored inside rows and columns inside a database. The first data can be, let's call it, your data is name of school, GHS Bamenda or GBHS Bamenda, Sacred Hearts College, and all the rest. Those are the names of schools that you have in Cameroon. Okay, and then you can store them in rows and their columns. That is a database. That is a table for you. That is what we call a table in a database. A table contains a table by name. Maybe schools contain the name of the school and the place where the school is located. We have maybe Sacred Heart located in Bamenda, St. Sylvester's located in Kumbu, maybe GBHS located in Bamenda. Those are all names and columns, and that is a table that you are going to form. Okay, now we have another type of data. This one is SQL or relational. You call this one relational. Now we have another type of data or database. We have another type of database engine. This database engine, instead of having rows and columns, it doesn't. It has but key value. It stores data in what we call key value. Instead of storing name of school, Sacred Heart, and place, origin or location, Bamenda, it will store it like this. It will just store a simple word like maybe name of school, Sacred Heart. Let me reduce the font size here for it to fit. Okay, name of school, Sacred Heart. You have first of all, school name, that is a key, and then the value is Sacred Heart, right? Then maybe this is the key value, name of school, school name, Sacred Heart, location, Bamenda. So this is how this other one stores data. This one stores data inside rows and columns. This one stores data as key pairs. Okay, so this is relational, this is non-relational. Non-relational. Now there is a myth that some people do not know. So many people do not know. This one is called generally as SQL. Okay, this one is known as SQL. We'll call this one SQL. And this one is called non-SQL. Generally it is written like this. Now, so many people will say that this one is SQL and it is relational. That means it is relational and it stores key data in rows and columns. And then this one is NoSQL. That means there is no rows and columns here. No, that is not the case. The NoSQL here means not only SQL. Okay. That is the meaning. That is not only SQL. That's the meaning of that. Which means that what? There is SQL and there is no SQL. That means in as much as this one can store data as key values, it can also store data as rows and columns. Okay. Can still store rows and columns at the same time. You are the one that decides which one that you want to store. Are you storing key values or are you storing rows and columns? You are the one that decides. Okay, so but this one stores only rows and columns. It stores data in only rows and columns, while this one stores data both as key values and as rows and columns. Now, coming to the reasons why developers will want to make some data key values and some data rows and columns, that is another debate. But you can go online and you look for the difference between SQL data and NoSQL data. Generally, you have most differences is that this one stores a very large amount of data and it can be queried very fastly. That is the NoSQL. Okay, when data is stored in key values, it can be queried very rapidly. The time of processing is very high, very fast, which is highly needed today, and it can be streamed and added more dynamically. But when it is stored in key values, the time of processing is low, and before you insert data, you have to set tables before you ever insert data. This one, you don't need to set any tables. You can send data. Some data comes in without a particular schema. Setting of table is called schema. If you want your data to have 3 rows and 4 columns, that is a schema. That's what is called a schema of the data. The data has 3 rows and 4 columns. That is a schema. But here, it is schemaless. You don't have a schema. You don't have a specific table for the data. So the data just come in key values and you can just be storing and going as you want. Okay, you can be adding other rows and columns as you want. And here, if you have 2 rows and 2 columns, the data should come in 2 rows and 2 columns. Here, you can have 2 rows, 3 columns in one data, and another data comes in 4 rows and 3 columns. So it is dynamic here, but here it is not dynamic. Okay, so that is the difference between a SQL data and a NoSQL data. So for SQL data, for NoSQL, we are going to use DynamoDB, and then for SQL we are going to use MySQL. I hope I was able to explain to any layman what a database is. It could be boring for those who already know what all this is, but it is necessary for those who are just coming in to understand what a database is. Okay, that is the explanation on what a database is. The next thing is, how do we handle it in the cloud? How do we treat a database in the cloud? As I said, generally you hear people talk about linking a database, joining a database, right? When programmers program their computer, program an application, they'll program the application in this way. This application will be programmed like this. Then inside this is a computer, this is a PC or an EC2, right? If we're talking about the cloud, in this same computer, they are going to install a database in the hard drive of the computer. Okay, the database is going to be installed in the hard drive of the computer, and then their application is going to be installed in the same computer. Okay, this is one way of doing things. The application is going to be installed in the same computer, and then they are going to connect the database with the application in the same computer, and then it is going to be distributed to the world. That means this same computer has the front end and this same computer has the back end, right? It is having the database, the back end and the front end. Okay, because the back end and both the back end and the front end is here. So many people do not understand this sometimes. Okay, both the back end and the front end is in this application. It's not like the back end is in somewhere behind somewhere. No, the front end is what you see, what has been completed, and the back end is the engine running the application. So a three-tier application is front end, what you see, what displays in front of you; back end, the program that has been used to program the application; and then the database, where data is kept when you put in data from the front end. So in this front end, you put in the application takes data from the front end, and then the back end processes the data that the application takes and then keeps it back, queries the database and keeps it inside the database. And then when you need back the data, you ask the application the data, the front end asks the back end then takes the data from the database and show it back to you. That is how it works. Okay, so generally it is not as if the front end is totally separated from the back end. No, it doesn't work like that. The front end and the back end are built together, okay, and they display themselves together. So but there are specialized people who can build the back end very well, and there are specialized people who can build the front end very well. When you can build both the front end and the back end, you are what we call a full stack developer. You are a full stack developer. You can build both the front end and the back end and attach to the database without any problem. You are a full stack developer. Okay, this is how people build applications, and this is how they install it in one machine. Okay, so in order to install this application, what you're going to do is you're going to install the database, which means that what you're going to install either MySQL, you're going to install either Postgres, you are going to install any of the engines inside your computer, and then you are going to install your application inside that computer, and then you are going to link it. Question is, how do we link an application to its database? We are going to come to that. Okay, we are going to come to that. All we wanted is for you to see how this works. Now this is the case where everything is happening in one machine, but as we all know, you cannot carry all your eggs and put in one basket. This is the olden way of doing things. This is no more the way we are doing things. This is all wrong. This cannot happen again in today's world. In the modern world, this is not happening anymore. Okay, this is just a local environment. This is just something to be testing whether your application is running. This is no more happening. You cannot talk about a real production environment where this is happening. What is a real production environment then, and what are we going to be studying? This is what we are going to be studying. In the AWS cloud or infrastructure, you are going to have your EC2 instance, which is going to be there in a VPC. Instance is going to be in a VPC, right? And that instance is going to be where? Inside a public subnet. Let us put the subnet in a different dimension. It is going to be in a public subnet, right? Separated. And it is going to now be connected to a database. It's going to be connected to a database, and that database is going to be in a different EC2 instance in a different subnet, which is going to be private. And then you will need to install your application in this EC2 instance, and then you connect your application to this database here. You're going to connect your application to this database here in this other EC2 instance or in this database. Now, in the cloud, in the AWS cloud, we are going to create this EC2 instance, this one, where our application is going to be installed. We are going to create it. But this other EC2 instance, we are not going to create. This is going to be created by our database engine. We are not going to create this EC2 instance. What we are going to create is a database. And from this database, an EC2 instance is going to be created for us automatically inside a subnet that we are going to specify. But we are not going to see that EC2 instance. What we are only going to see is a database. So it is a whole EC2 instance that has been created and with a database installed inside. So all you need to do is connect to this database, right? And we will see a situation where we are going to create two EC2 instances, maybe in different groups, subgroups, subnet groups, and we connect to the same database. That means we can create another subnet or another EC2 instance like this. We create another EC2 instance in another subnet, and we still connect it again to our database. Okay, we'll connect it to our database, which means that what? We are not using that old method of inside one EC2 instance, you install a database inside, and then everything is found inside. No, we are not using that method. And why is the cloud so important to us? Why are we doing this in the cloud? Why do we talk about the cloud and like going to the cloud so much? The reason is because now imagine you have done everything in one EC2 instance. If that particular EC2 instance gets attacked, that is all finished. Now, what if this infrastructure like this, you can tell me that yes, but you can set up this infrastructure in your environment at home or in your business center. Yes, you can do that and have a special machine dedicated as a database and a different machine dedicated for your front end and your back end. Now, if you do this and this database in your local environment gets attacked, that is all for you. That is all for you. It's finished. Or you can tell me that you can make two of them. Yes, if that building gets caught up by fire, that is all for you. You are finished. because in your environment you are going to build a house, and then you are going to buy like 3 computers and stock in three different rooms and say that you are secure. If that building gets caught by fire, you are gone. That's everything about you. Everything is finished. So in the cloud, how do we handle all this? Now we are already starting to talk about backup. Okay, backup. Now in the cloud, when you are creating this database, it is automatically backing up. And where is it backing up? In another region. Know the way AWS is structured. This is how AWS is structured. This is a region in Europe. This is a region in Africa. A data center in Europe, a data center in Africa, a region, please. And then this is another one in maybe Asia, and this is another one in the United States. This is how they are. This is a data center. These are data centers. Okay, these are data centers. In the one in the US, this is a data center in the US. In the one in the US, we have different zones. We can have North Virginia, we can have Oregon, we can have maybe California, just like that. Okay, and in the one in maybe Europe, we have Paris, we have Luxembourg or Germany, something like that. In the one in Africa, data center in Africa, we have maybe Cape Town is somewhere here. We have different multiple availability zones. In the one in Asia, we have maybe Singapore, maybe India should be there, something like that. I don't know. So this is the way AWS is structured. These are data centers and these are availability zones. So you can decide and say that, okay, my data is found in North Virginia. My EC2 instance is here. Your EC2 instance is here in North Virginia. This is your EC2 database in North Virginia. And then you can decide and say a data backup will be in Oregon, or it will be in California, right? So it is only witchcraft that can make Oregon, California, and North Virginia, all the 3 of them go down at the same time. But let's consider that there is a situation like that, and this region goes down, all of it goes down. You have your option of backing your data in Paris or Germany. It can never happen that all these 3 regions in different sites go down and these other availability zones in this other region goes down. It's difficult to happen. That's why AWS will tell you that our database is secured 99.9 to the 19 power, that you are secured. And that is why we say the cloud is more secure than the local environment. Okay, so that is the reason why we always advocate for the cloud, because of this security and backup. So we are going to look at automatic backups, multi-availability, and the last thing we haven't looked at is a read replica. So for multi-availability, we have said that in the cloud, your database is available in nearly the whole world. You can decide your database should be available nearly in all the whole world. Okay, you are saved and you are secured. Now, a read replica. Imagine a situation where you have the database engineer. Generally, you always have a DBA, right? You always have a database engineer who is going to be your DBA master. Okay, and then you have an accountant. The DBA is the one that can enter into your database here. The DBA can enter into your database here, right? DBA has the right to have access to your database. Now, he can read and write into this database, as well as the application, because the application is the one that is providing the data to the database. Okay, the application is the only thing that provides data to the database, so that data should be authentic. The data comes through the application and then it enters to the database. So the DBA also can now enter directly to the database and write into the database. So if a DBA is a malicious DBA, he can insert some data directly into this database which did not come from the application. Okay, data that should be inserted into this database should come from the application, or it should be data that is transferred from some database which was maybe somewhere and populated here, so that this application should continue to be adding to the data or searching from the data. Now, what if it is financial data and it is showing that your salary is maybe 2 million, and then DBA comes in and adds something to it that is a faulty thing? So the DBA should be held responsible. Now imagine an accountant who knows how to cover his accounting steps has access to this database, to this financial data. That accountant can write anything in this database. So for that reason, some databases are provided which do not have write possibilities. That's how we call them read replicas. So in the cloud, we have a possibility of providing the replica of this data exactly the way it is. This data like this is replicated for the accountant. In this other database now, the accountant can enter into it and only extract data. He can only read the data, but he cannot write anything in the data. The only person who can write to the data is the DBA. But the accountant now will only read from the data. He cannot write into the data. That's what we call a read replica. Okay, it is called a read replica. So in the cloud, we have multi-availability. That is the advantages that we have in the cloud. First of all, automatic backup. The data is backed up automatically. You can not lose your data. You back up your data automatically. We have multi-availability, which means the data is available in different centers all around the world. And then we have a read replica, which provides access to those that are using the database, but they cannot write into the database. Okay, so let's go now and create a database in AWS. Now in AWS, to create a database, you just come here, you write RDS, which stands for Relational Database Service. Okay, then you click on RDS. Now it will come. You have no database. You go to database, you see I have no databases, and then I click on create database. Okay, when I click on create database, I just want the standard create. There is an easy way of creating. You just click on easy and everything is chosen for you. We'll go by standard way of creating so that we have the autonomy of choosing several things. We said our key study should be MySQL. Okay, that's what we are studying, MySQL. And then we are taking the community. Here there is nothing to configure. And then this is the latest version, which is 8.3. Where is it? 8.0.35 as available. You can choose your particular version which you are using, right? 3.6 can still go, but let's go to 3.5, which is more stable. The latest version is still very still shaky. Let's go for 3.5. And then, are you in production? Look, when you click that you are in production, it takes multi availability zone by default, because production you should go for multiple availability zones, right? But when you say you are in free tier, now they know that you are just practicing. Okay, they just put that off. All right, now you come down to your database name. Let's put this one, practicing database. This is the name that you are going to recognize your database with. So it is called practice. We call it practice DB, right? Then we come down, allow the credential, master name, admin. Generally we allow it like that. Self-managed, yes. We are going to manage our database. The master password, let's go with training. I'm putting let us write everything we're putting down so that we should know what we have, because those are things that we are going to need in order to log into our database. Okay, we said our database name was practice DB. Was it? Let's check. Practice -DB. Database was practice -DB. And then username, master username is admin. This is database name, and then this is master user name. And then the next thing is password. Let's take the password to be training 123. Okay, master password should be training 123. We confirm it, training 123. And then we come down. So we see down here we have storage. Okay, allocated storage will go for 20 GB, but you can reduce it or you add it. That is your choice. You can go for whatever you want, but this allocated storage is going to scale up automatically. You see, it's going to be scaling up automatically, which means if this 20 GB is consumed, more storage is going to be adding to it. Okay, so you see by default it has automatic scaling. You are the one now that should come and say no, it should scale up right to which level. It can scale up right to 6,144 GB, but we have put a maximum. The default maximum here is 1,000. It should scale up to 1,000. As much as it is scaling up, that is how your space is being consumed. So you can see an enormous amount of data space that is available in the cloud. Okay, then you come down. So you see auto scaling is automatic. It's enabled automatically. Then you come down, you can connect to your EC2. You cannot connect. For now we will not connect to our EC2. Okay, we don't want to connect to our EC2. And then let us just have here you choose your VPC. Which VPC are you creating your database? So let's just go for the default VPC for now. In our project we are going to create a different VPC for the database, so let's go for the default VPC. Now we come down, The database subnet, yeah, we are just going to go for the default database subnet, but when we come to the project, I'm going to show you what is a database subnet group. Okay, a database subnet group, we are just going to go for the default for now. Everything is okay here. Do you have one public access to the database? Let's say yes for now. I want a public access to the database for now. We need public access to the database, but generally you should not give a public access to your database, and we will see how that is being done in the project. And then VPC security group. For the security group, let us create a new security group. Okay, let us create a new security group for our VPC. We call the security group DB security group. Availability zones, any availability zone will do. And then everything looks good here. Additional configuration, the port number for this database security group should be 3306, which is open. Very important. If it is not open, we are not going to have access to it. That is the port number of our database, so our security group should have that port number well opened. And I think we have everything we can have. Additional configuration. Now here you are going to give the initial database name. This initial database name is very important. It is the table that is going to be created inside that database. In database terminology, we call it a schema. Okay, so for example, let me show you one example here. For example, if you have a database, okay, you can have so many tables. As I did say, a database is made up of a combination of rows and columns. So you can have a table up here. You can have a table up here. Okay, you can have this table like this. All right, and now you can still have another table here like that. Pardon my lines that are not straight. You can still have another table like this. So you can have different tables. These tables, right, in the database terminologies, we call them schemas, and they have specific names. So for you to create a database, you have to create and give a default name for the first schema or the primary schema that you are creating, because if you are creating a database, definitely you are creating it with a schema, with a particular table. So you have to give the name of that particular table. So that is the name that we are going to provide here. So let us give that name, and the name is also very important when you are coding. All right, when you are coding, that name is important. For now, let us allow the name. We are going to create the name in the code that we are going to be using. We are going to create the name, so let us allow the name for now. DB parameter group, allow all these default options is okay for us, and we can create our database. So the database takes some time to get created. Okay, it actually takes close to about 5 minutes or 3 minutes to get created. So for that time, you have to hold on while the database is creating. Okay, because you generally know the database actually creates an EC2 instance. As we said, it creates an EC2 instance, and then inside that instance it is going to install the database engine, which in our case it is MySQL. So for that it is going to need some time. So let me fast forward the video rather than waiting. Okay, our database is now available. You see, I waited for almost close to 5 minutes. Our database is now available. Now we have a database. What do we have right now? We have a container, an EC2 container with a database inside. Can we see this container? No, we cannot see it. Can we see that EC2 container? We cannot see it. If you go to your EC2, we are in Oregon. If you go to your EC2 and you go down to Oregon, and you look at instances, definitely you are not going to see a database, an instance created here. Okay, you are not going to see an instance created here, which means that what AWS is managing this database. I have no instance, which means AWS is the one that is managing this EC2 that is hosting this database, and AWS is the one that has installed MySQL inside. Question now is, so how do we get access into this database? How do we enter inside this database before we can actually even see the data that is inside, or before we can actually input data inside? How do we enter the database? Okay, the first thing I'll tell you is that when the database finally gets created, there is a connectivity that is created, which is called the database endpoint. That is what connects you to the database endpoint connector. So how do you see this database endpoint? How do you get this connector, this connectivity between you and the database? How do you see the connector? You click on the database, and then you come down to connectivity. You have monitoring on WADA. You come down to connectivity, and then you scroll down, and then you see endpoint. Endpoint is here. So you copy this endpoint. That is when you have the endpoint in combination with all these things that we had here. Remember that we had database name, which was practice database, master username, which was admin, password, which was training. Then another thing that you have, actually it is the first thing that you even need, which is called the endpoint, host endpoint. That is what we have now. So we have all these 4 things. So with these 4 things, you are capable of connecting to your database without any problem. Okay, with the 4 connections, you are capable of connecting to your database without any problem. But the question still remains, how do I connect to this database? I have the database here in an EC2 instance where the engine has been installed. But how do I connect to this database? In order to connect to this database, you have a tool. So you have your database, your machine, and then you have your database inside your machine. Okay, a database is installed inside your machine, but in order to connect to this database, you need a tool. Okay, there is a tool that you are going to connect to that tool, and then that tool will be the one to access the database for you. There are so many tools in the market for this, but we are going to use Workbench because Workbench is actually very adapted for AWS and for MySQL. Okay, we are going to use a tool. So for us, for our tool, this tool is going to be Workbench. Where do we get the Workbench? It is downloaded from the internet. Workbench. Okay, this tool is downloaded from the internet. Okay, so if you just go to the internet, or I'll send you the link in the comment section, in the description below, I'll give you the link. This is the link that I have here, where you can just download Workbench very fast. You have Workbench. Okay, let us click on the link, which will take us directly to Workbench. So you have Microsoft MySQL Workbench. Okay, now when you come to download Workbench, when you come to this page, you come down here and you click on download. Definitely you should be using Windows. You click on download. When you click on download, it will ask you to log in. There is a small writing here, no thanks, just start my download. So if I click on this one, it will start the download. Okay, but I already have the program downloaded and installed. It's a simple program, just download it and click next. It will install for you. Okay, when you download and you install it and it is installed, you just come here and then you search for Workbench. I've already downloaded and installed it, and when I search for Workbench, now in order to install this application, you need to have Microsoft Visual C++ 2019. Okay, you have to install Microsoft Visual C++ 2019. If you don't do so, it is not going to install. What is Microsoft Visual C++ 2019? Let me show you my computer. I can go to my computer here. All right. So this is what you should have. I have my own Microsoft Visual C+ 2015. So you should have at least from 2019 upwards. Mine is Visual C+ 2015. Okay, so you should have this installed in your system. If it is not installed in your system, your application will not work. Okay, so make sure it is, your Workbench will not work. So make sure it is installed in your system for your Workbench to work. So when you open this Workbench, if it is already installed in your system, your Workbench will work. Of course, your systems, with all the trainings that you have been doing, I'm certain that you should you must have installed it somewhere. Okay, so when you install Workbench, let me delete this connection. When you install Workbench, the first thing you are going to do is this page will welcome you to Workbench, and you open it. This page will welcome you to Workbench, and then you go to databases and you click on manage connections. When you click on manage connections, what comes is this. Now you're going to create a new connection. Come down to new down here. you click on new. Now when you click on new, you write the name of your connection. We are creating a training connection. Now allow standard TCP because we are directly accessing our connection. You see that port is 3306. Now here, host name. Where you have the host name, you have to put your you remember your endpoint. That's where you have to put your endpoint, where you have your host name. So we go and look for endpoint. Okay, this is our endpoint. Copy your endpoint and you paste here. And then for root, remember that we had admin. And then for password, you open this store in vault, put training 123. Okay. And then for default schema, right, we do not have a default schema. Let us connect test connection. So successfully made the MySQL connection. Okay, we have successfully connected. When you are connected now like this, the next thing is you come back to, you close this, and then you come back to databases. You come to connect databases now, and then you are now at your training connection. You want to connect? Okay, I want to connect. So I'm opening my database now to connect to my session, to connect to my database. Okay, now I am connected to my database. I am connected to my database. There is nothing in my database. There are no tables. There is nothing. My database is empty. If you come here, you see nothing is there. Database is empty. Refresh. There is no table in my database. It's just the system configurations that are there. Nothing actually. Okay. So how do I then create tables? I have a file of commands on how you can do most of those. The first one is create database. So let me just copy all these commands and then I paste, and then will be executed one after the other. Copy all the commands. And paste here. So these are the commands. The first command is we are going to create a database. Is it create database? So I click on that command, control enter. You see a database is created. Okay, then I say okay, use the database, control enter. I am now using the database. Okay, then I say drop table if existing, if exist inventory. So if there is any inventory table that is existing, it should be dropped. Okay, there is none that is existing, of course I know that. Then I say my next one, now I say create table inventory. Okay, I now create a table called inventory. Now the table has been created. I'm inserting now values into the table. Okay, I want to insert value. So the first value I'm going to insert is banana 150, orange 154, apple 100. So let us insert these three codes. Control enter, install, it inserts. Control enter, it inserts. Control enter, it inserts. Okay, Next thing is I have inserted values into my database. How can I see those values? There is a command to see the values which I'm inserting. So this is how a database engineer or a DBA can enter into your database and start adding values into a particular table, or subtracting values from a particular table, or deleting values from a particular table. This is how he will be doing it. So I have inserted all these values. I want to see the values that are there. I click on this command to see. I'm reading now to see the values that are there. Control enter. Right, if I click on that, control enter, okay, you see what is happening here. I say select star from inventory. That's select everything from the table called inventory. I see it brings me that 1 is banana, the quantity is 150. 2 is orange, the quantity is 154. 3 is apple, the quantity is that. Okay, and then I can say okay. I click on update inventory, control enter. It updates the inventory. You can reduce your output environment. And then I say select star again from inventory to see what I updated. You see, I updated, instead of banana being 154, but the former number, it is now 200. Okay, so this is how you can interact with your database. I can delete inventory and it will get deleted, and then you say select star to see whether it actually got deleted. You see, I deleted what? Deleted the last table, and there is nothing there. It is actually written there, null. So I am interacting with my database. I am querying my database. I created a database. This code actually, let us bring the code for you to see. This code actually created a database. This is the code. The first command is this one, which is create database called quick start DB. It created this table, right? And then this one says, okay, use the database that you have just created, right? Now the code is using the database. The database is the one that is available. Now I said, if there was any database that was existing at first, drop it. That's delete the database. It told me that there was no database, so there is nothing to drop. Now create me the table in that database quick start called inventory, and inside that table you are going to put this particular type of figures to be entered into it: varchar, a serial, and all the like. For you DB engineers, you understand all this. And inside this table, insert me these values. I want the first value to be banana, and the quantity should be, the name should be banana, and quantity should be 150. And then I have the second value to insert. The name should be orange, and the quantity should be 140. The third value I want to insert is, the name should be apple, and the quantity should be 100. After you have executed all this, now you tell yourself now that select star from inventory. That means select everything from the table called inventory. Now that is when that table came out and presented to us everything. When you run this this command, this table came out. We run this command, this table came out here and showed us everything. Okay, that's when you say select star from inventory. Now update inventory set. Update inventory set quantity equals to 200, where ID equals 1. Which one had ID 1? Okay, so the ID is increasing in a serial way. When they say ID is increasing in a serial way, that means first value is 1, second value is 2, third value is 3. Now when they say update inventory set quantity equals 200, where id equals 1. It means where the id equals 1, certainly it should be at the first entry, where id equals 1. Set quantity to equal to 200. So instead of 150, the banana now will be 200. That is how the database engineer will change the quantity directly. Okay, then select star from inventory. He will see what he has changed. Then delete. This one is called CRUD update. Okay, what the DBS call is CRUD: create, update, and delete. That is CRUD: create, read, update, and delete. That's the meaning of that. Then select star from inventory. So this is what database is all about. Right, there is still one question that I know it is running in your mind, and the question is, okay, it is the DBA that is doing all this, which means that what? Which means that here we are. It is a DBA that is doing all this from our workbench, but we are always talking about applications. What of an application? We want an application to be doing all this to the database. We are going to see it in the project that we are going to build, so don't fail to follow up the project. The project is coming up immediately after this video. All right, I'm certainly going to put the link of the project below this video for you to follow up and see very well. All right, so that is it for relational database for us, how to delete your database. Now when we created this database, let's first of all talk about how to create all the multi-availability zones and everything. When we created this database, we had, this is our database, or asking me to log in. Okay, when we created this database, we said we can do multi-availability, we can do automatic backups. Okay, so how do you do automatic backups and how do you do multi-availability? If you select your database and you come to actions, you will see first thing is convert to multi-AZ deployment. Okay, that means that what, you can change this database and it will be deployed into different availability zones. Okay, you can change it from here and your database will be automatically deployed to different availability zone. You will do that setup. I will not do it for you. You go and you find it out when you are in production, and then when you come to the same actions here, you are going to see create a replica. Okay, you're going to see create replica. When you create a replica, the replica of the database is going to, a read replica is going to be created in a particular region or zone that you want to create, where maybe your assistants will be accessing the database. Okay, now how do you take snapshots? Because snapshots are a form of backup too. You can take up a particular snapshot at a particular time and then you back up your database from that snapshot, but automatic backups are being taken automatically. There is automated backups. When you come to automated backups here, you will see your automatic backups that are being taken automatically. I told you that backups are automatic, they are always there. And then snapshots, you create snapshots to occur at a particular time. You can set up all this the way you want, play around with the database the way you want, but mind you, it costs you some money when you are playing around with your database, because AWS does not clown when it comes to data. Okay, they don't actually clown at that level. All right, So this is for relational database. Let's move on to non-relational database. Let's delete our database. You just come to actions, you come to delete database. There you write delete me. So your database will take some time to delete. Okay, it will take some time to delete. So while our database is getting deleted, let's go over to MongoDB. Did we say MongoDB? We said we are going to do DynamoDB. Okay, for DynamoDB, we did say there are just two things that we are going to talk about in DynamoDB, which are primary key, which is the partition key, and composite primary key, which is the sort key. So what is the primary key and what is the composite partition key? All right, generally we said it is storing data in key values. If it is storing data in key values, then this is the way it is storing its data. Okay, that means it is storing its data in the form of just words. Maybe it will store its data like this: name, John, right? Country, Cameroon, right? Gender, maybe female or male. So this is how it stores its data. Okay, now generally in the study of data, in data science, there is always a value that you should, a column that you should use, that should some sort of a way be identical through which you can sort out the data. There is some sort of a way through which data can be classified and sort out. So we have two ways of doing that. We either have the partition or the sort key. Have the partition key or the sort key. What is the partition key? Let me give you two characteristics about the partition key. The first thing about the partition key is that the partition key does not take duplicate values. A partition key does not take duplicate value, and a partition key does not accept null keywords. So these are the two principal characteristics of a partition key. So let's see data in which a partition key actually takes effect. Now, if you are in a school and they want to register you into that school, obviously they will start with matricle, right? You have a matricle, and inside that matricle they can give you, your matricle should be like 0, 1, 0, 1, no, 0, 0, 1. That is your matricle. And then on top of, after that matricle, you have a name. So you have name, which will be John. And then the second thing is we have 002, and then that name should be Paul. Now we have 003, and the name should be Mary. Now it says that a partition key does not take duplicate values. Then in this table like this, you cannot have the fourth entry be 002 with a name Jennifer. You cannot have this. It is wrong. The partition key should increase serially and does not take duplicate. So this is a partition key, and this repetition, because this one is already here, it cannot more work. So this data can be identified from these figures. The only thing that can work here is 4. So for you to use this data, you need to use its partition key. When you bring out a partition key, you will get a full data stream of a particular set of data that was entered. Okay, so no two data sets can have the same partition, and the partition cannot be 0. That's what we talked about partition. The partition cannot be null, which means I cannot just come and put maybe Laura here just like that without putting a particular serial number here or a particular partition here. I cannot do that. Okay, so this data has a partition key. This is what we call a partition key. It is a number, or it is an entry in a column that is not duplicated and does not accept null keywords. It is not duplicated and does not accept null keywords. That's a partition key. Now we have a situation for a sort key. What is a sort key? Take for example, we have a bank or an office which is found in so many different places in the world, and it is coded. The office in US is coded US 001. The office in the office in France is coded FR 002. The office in Cameroon is coded CA 003, just like that. Okay. Now we have employees. There is John, who is in US. There is Paul, who is in France, and there is Mary, who is in Cameroon. Question is, can Jennifer be in France? Can Jennifer be in France? Of course, yes. Jennifer can be in France. It accepts. Jennifer can be in France. But can Paul be in France at the same time? No, Paul cannot be in France at the same time. There's Paul up here who is in France, and there cannot be Paul here who is in France. It doesn't work like that. Okay, it doesn't work like that. But can Paul at the same time, but can, let's say, John at the same time be in US and at the same time be in France? Can it work? John cannot be at the same time in US or at the same time in France, but this value, this entry can actually go in. Okay, it can actually enter, because if John is working both in France and in Paris, in US, it can go. Okay, so partition key, their own characteristics is that accepts duplicate but different values. You see, accept duplicate, the key here is 002, FR002, and there is a duplicate FR002, it accepts the duplicate of FR002, but the values should be different. So it's a key that accepts duplicate but different value. So when we talk of key value pair, this is a key, this is a key, and this is the value. That's what we call key value pair. All right, that is NoSQL. This is NoSQL. This is the way data is stored in a NoSQL database. So let's go and create MongoDB, DynamoDB, please. We create our table. Here we are not creating any EC2 instance. The database is already available directly in the cloud. No EC2 instance being created. Okay, we give our database name, which is training DB, and then give our employee name, our database partition key. The first thing is partition key, which is employee number. Then the second one is employee name. Okay, so all of them are string. So we have given our partition key, we have given our sort key. Okay, all these are the sort key is optional, but the partition key is obligatory. All right, everything about our database is set to default. We create our database. So you see the difference between a SQL database and a non-SQL database. We waited for how long before our relational database was created, but as we create a NoSQL database, it is created automatically, barely without any difficulty. Okay, it is already active. So let's click on our database. When you click on your database, you're going to see your database is ready. Now, do we need some sort of a workbench like this one to interact with our NoSQL database? No, we do not need a workbench. We just can directly interact with our NoSQL database without any problem. Okay, all we need to do is just come here. Our database is already there, ready for us. All you need to do is you create and you enter data directly from the EC2, the AWS console. You have all your analysis here. You can enter your data directly here as you want. So that means you can perform all your CRUD operations from here. You have your indexes, right? You have your monitor. So a whole data stream is an index. If I click here, I will see my various index. Okay, a whole data stream is an index. Okay, so if I want to input some data into this database, I'll come to index and then I will be putting. So here you can see where to delete, create items and all the like. Okay, if you click on create items, here you are to put now values into your database. Okay, employee number, I can put my employee number as unfortunately I put it as string. So if I put 001, it is my employee number. Employee name should be Kevin. Okay, I create my item. You see the database, the data is inserted directly without any problem. I can go again to here. I click again, employee number 002, employee name Andrew, and I click enter. Now in the third table, instead of doing that, I come to create data, and then there is an employee now who has a number a name, an agenda. So I just come here, I say add maybe a string, and then I put gender, right? And then I put 003. I put Chelsea, and then her gender is female. The first data that I put, there was no gender, right? But this one, there is gender. I put create enter. The data goes in directly, right? But with SQL, all the data must have all these values. You see the difference? So NoSQL is dynamic, while SQL is some sort of very stiff and static. Okay, so directly from here you can sort your data and do everything. And how are we going to see this one in action? We are going to incorporate this one with Lambda, write a Lambda function that will create all this data that we are creating manually. A Lambda function will create all the data for us automatically, and everything will be uploaded and will query it. Okay, so this is how a database is done in AWS. This is how database functions in AWS. So we have taken a recap. We have used MySQL as relational database case study, and we have used DynamoDB as a no relational database case study. We have seen what is a partition key, and we have seen what is a composite key. We have seen how all of them are in action. We have seen how AWS can automatically back up its database. We talk about automatic backup in multi-availability zones and in regions, and we talk about how you can replicate your database in a read format so that other people can have access to your database. So this is a comprehensive, I think the most comprehensive basic course about the database of AWS in the internet that I have seen. I have taken some time to actually explain all this from a very layman's point of view. So hope you take your time also and follow it, practice it. For those newbies who are coming into cloud and do not know much about databases, take some time, follow it and practice it. And the project that I am talking about, make sure that you go through the project and make sure it works for you. If it works for you, then you are well to do. Okay, thank you guys very much. Practice always makes perfect. Okay, see you in the next video. Bye bye.